Right. Unit 2 review. I know I keep saying 1, but I think you guys got the point by now. Unit 2 review. Given that each pair of figures are similar, find the missing side. So our missing side in this first question is here. We always want that to be the numerator. The corresponding side would be 24. And then this was our numerator, so 10 over 15. X divided by 24, we always multiply by our denominator, which is 24. And that goes to the other side, 24, so cancel, cancel. And if you do 10 times 24, you get 240. And then you divide 240 by 15, and you get 16. So first question, our answer is 16. All right, next question over. Our x is here, so we'll do x up top over 35. Actually, you would write that somewhere different. Not enough space on this one, sorry about that. X over 35 is equal to, this one looks like our long side, 54. Actually, it is our long side. It's the bigger number, over 63. Just like the last question, multiplied by the denominator. And you're going to do 54 times 35 divided by 63, and we get 30. X equals 30. And finally, this last one, here's our x. So x over 5 is equal to 8 over 4. Multiply both sides by our denominator. Cancel, cancel. X equals 8 times 5 is 40. Divided by 4 is 10. All right, solve for x. The first thing you want to do is multiply by the denominators. I'm going to do this one first. Just put this on the left side for no good reason at all. Boom, boom. X minus 2. Cancel, cancel. We have 3 left over. We have to distribute this 6 to both. So 6x minus 12 over x plus 4. And now we're going to multiply by this denominator. Cancel, cancel. Our right side is 6x minus 12. Our left side becomes x times 3, which is 3x, and then 4 times 3, which is 12. I'm going to move my x's to one side, so I'll subtract 3x here. Cancel, cancel. So 6x minus 3x is 3x. Then I'm going to add 12 to both sides. So that cancels. We get 12 plus 12 is 24. Last step is to divide by 3. X equals 24, divide by 3, which is 8. Determine whether each pair of triangles are proportional or is proportional. So we have side 5 corresponds to side 10, then 8, and 16, and finally 3 and 9. So 5 over 10, is that equal to 8 over 16? Is that equal to 3 over 9? Both of these equal 1/2. This one equals 1/3. So they do not equal, therefore they are not similar. Determine if the given pair of triangles is an enlargement or reduction. Then find the scale factor. All right, well, first off, these little like notches or primes tell you which one's the new. And the formula is always new over old. So I'm going to pick one number out of this. I'm going to go to the smallest number. These small numbers are usually easier to work with. That's up top. And our smallest number over here is 2. So our scale factor is 1/2, which means it's less than 1 and greater than 0. So it's a reduction. Same process over here, new versus old. This triangles are new. That'll go up top. Small number is 10. And small number over here is 4. 10 over 4 simplifies to 5/2 or 2.5. That is greater than 1, so it is an enlargement. All right, dilate the figure by a factor of 2 with the center of dilation at the origin. Okay, this one's at the origin. Our next question over here, we don't have an origin question, so it's a little bit different. List the coordinates of j, k, l, and j prime, k prime, and l prime. So j's coordinates is 2, 4. K is 1, 1. And L is 4, 0. We're going to multiply all these numbers by 2 because we're at the origin, so it's a little bit easier than the next one. So 2 times 2 is 4. 2 times 4 is 8. Both these are 2, 8, and 0. Now let's plot all of these. 4, 8 is there. That's J prime. Then K is 2, 2. K prime. And finally L prime is 8, 0. Connect our dots. And we're done. Dilate the figure by a scale factor of 1/4 and center of dilation at -8, -3. List the coordinates. So first off, let's list the coordinates. A is at 0, 5. B is at 8, 1. And C is 7, -8. Okay, we can't just multiply these numbers by 1/4. We actually have to count from P over to our coordinates. So from P to A is 8 units. And then up is also 8 units. So let me erase these. I just want to show you what I was doing. 8 times 1/4 is equal to 8 over 4, which is 2. So instead of going over 8 and up 8, we're going to go over 2 and up 2. So over 2 up 2 is right there, and that is A prime. Now let's count over to B. We know from here to whoops. So -8 all the way over to +8, that is 16 over. 16 times 1/4 is 4. So we're going to go over 4 instead of 16. And then also counting up to B, it's 1, 2, 3, 4 up. 4 times 1/4 is 1. So we're going to go over 4, and we're going to go up 1. So right there. So 1, 2, 3, 4, up 1. And finally, let's count over to C. So it's 8, 9, 10, 11, 12, 13, 14, 15. So 15 over 4 is 3.75. And then down to C is 1, 2, 3, 4, 5. 1, 2, 3, yeah. Which would be 5 over 4. So we're going to go over 3.75, 1, 2, 3.75, which is right about here. And we're going to go down 1.25, which is right about there. So that's where those two lines intersect. That's our new point. So right there. B prime, C prime. There we go. All right, this is a little harder to do on the board than it is on paper. It says find the center of dilation and the scale factor. So we're going to first draw some straight lines. Hope I do this right. That was off. Let's try that again. It's off again too. Okay, it's a little better. And finally, from A to A. All right, actually turned out pretty good. So that looks like it's our center of dilation, which is over to 8 and down to 7. So center is 8, -7. Now we got to find our scale factor. This big triangle is our new one, so that number is going to go up top. I'm going to count from B over to my center. So from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 over. So 16 goes up top. That's our new. And now from our old, 1, 2, 3, 4. 16 over 4 equals 4. So our scale factor is 4. So 4 times larger. All right, state the appropriate triangle similar postulate for each of the following pairs. All right, so this one looks like we have 3 sides. So we're using side, side, side. I'm going to do the big triangle up top. So we'll do 7.5, that's our smallest number, over 3. Our medium number is 25 over 10. And finally, 30 over 12. And that'd be side, side, side. So take a calculator to confirm that these are all actually the same number. We do 7.5 over 3, which equals 2.5. So that needs to be the same for the other two. 25 divided by 10 is also 2.5. And finally, 30 divided by 12 is also 2.5. So because of the side-side-side similarity postulate, we do have two similar triangles. This one, we have vertical angles, and we also have two sets of sides. So we're going to do 8 over 24 equal to 14 over 42. 8 divided by 24 is 0.3333 repeating. 14 over 42 is also 0.333 repeating. So that checks out. And we have angles that are congruent. So we have side, angle, side similarity. Next one, three sides again. So let's check it. Small number is 8. Actually, I'll do the big numbers up top. So 48 is here. So 48 over 8. Our median number is 72 over 12. And finally, we have 84 over 14. 48 divided by 8 is 6. 72 divided by 12 is also 6. And finally, 84 over 14 is also 6. But because of side similarity. This one, we have angle T, angle J, angle U, and angle K. So all we need here is the angle similarity. We have two angles that are congruent, therefore those two triangles are similar. Last one on this part, we have vertical angles, so those are congruent. And then we have another angle here with an included side. So we have angle, side, angle. And actually, we don't even need that side. All we need is two angles to prove that they are similar. Actually, what this proves is that these triangles are also congruent. So angle, similarity. All right, I'm going to make a second video. I am hitting my 15-minute mark here, so I'm going to stop this one now.